All right, everyone, welcome back. We have Tvrtko Sternak, who is going to be talking about FastStream. It is a Python library that makes connecting to messaging queues easier. So give a warm welcome to him. He's coming all the way from Croatia. Thank you.
Hi, everyone. So my name is Tvrtko. When I finished college, I started working for a firm that was developing microservices that were connecting to Kafka. It was not in Python, it was in Scala. But when I swapped firms to ERT, we had some issues of connecting our models, not by REST API, but connecting them to Kafka, which I'll talk about in a minute. So we used my knowledge of Kafka and my boss's knowledge of Python to create FastStream. So yeah, FastStream is basically, it started as a Fast Kafka, and it evolved into a framework that makes your connecting to messaging queues easier, testable, and like more readable without boilerplate. So we're basically an AI firm. So we develop models for our clients, and our usual way of putting those models into production was to wrap them into some kind of REST API. We usually used Fast API because it was clean and easy. And so to wrap our model, is it better now? Yeah. Yeah, so to wrap our model into a REST API, the steps were like 5 lines of Python code. You create your Fast API application, you define a GET endpoint, and inside of GET endpoint, you receive the data, make your prediction, return it to the requester. So, and it works really nice. So app.get handles your message routing. The input data type is being decoded automatically by Fast API using Pydantic. And then the prediction you are returning is also being encoded into JSON automatically. You don't need to worry about anything. And after talking with our clients, we've noticed that we have several projects coming up that don't use REST API. So they internally in their companies use Fast Kafka for communicating between their services. And we said, like, that's completely fine. We'll develop the model and we'll find something that looks like this. Because if Fast API exists, something like Fast Kafka should probably exist. And it would like do the same logic as Fast API, just with messaging queues. So the publisher and the subscriber decorators would handle your message routing. And inside of it, the input data would be parsed from the Kafka messages. And when you return a prediction of your model, it will be encoded into JSON or some other format and produced to a prediction topic. Guess what? It didn't exist. So we decided to join our forces and to develop Fast Kafka. We took FastStream as a big inspiration, and we copied like using Pydantic for encoding and decoding the messages. Under the hood, to connect to Kafka, we were using AIO Kafka. And to generate the documentation of the applications, so all of these produces, consumes endpoints, we were using Async API. And while we were developing this, and we released it like officially on PyCon in Berlin last year, there was a guy in Russia who was developing Propan, which was practically the same thing, but not for Kafka. It was for AOPK, for connecting to RabbitMQ. And we've seen like his project getting track, and we've decided to join our forces and connect Fast Kafka and Propan, abstract the library, and offer to our users, to the people who would use FastStream, the ability of defining the logic of your application in the same way that you would use for Kafka or Propan, and make it interchangeable. So to change from from fast Kafka to RabbitMQ, you would just like to have one line change of not using Kafka broker, but using Rabbit broker. So let's go through some of the basics, and let's see how you can define consuming messages from Kafka. So the first line, you would define your Kafka broker from FastStream, which connects, in this case, to localhost 9092, and create your application that wraps your Kafka broker into a FastStream application. After that, you define your async function for processing the input messages from the input data topic, and you decorate it with the @broker subscriber and define the topic that you're consuming from. And that's it. So to consume something, it's 5 lines of code plus your processing logic, and you're like done. You're connected to Kafka. To produce something, in this case, we are producing as a reaction from input data. So we, again, define our Kafka broker, wrap it up into a FastStream application, and each time our on-input data is called by the subscriber when we get a message from the input data topic, we will do some processing and return a prediction, which will get encoded into JSON, and the broker.publisher decorator will catch the return value and produce it to a topic called prediction. So if you want to use a publisher by itself, not as a reaction to some messages that you're getting, you can always define your broker.publisher to the prediction topic, start up your broker, and then just call the function. Await it because it's async. So what's interesting in this is that you can also use your broker. You'll see how usually we start up a FastStream application. But if you want to use it like in a script, you can always start up your broker inside a script using async with. And the broker has defined the context manager functions. It will start up by itself, and then inside of it, you can count on that your consumers and publishers are connected to your message queue, and you can start publishing and consuming. The next thing that we wanted to do, so we wanted to have a nice way of testing our applications, and usually it was like in other libraries for Kafka, it was a bit brute forced. We wanted to have some like synthetic sugar, and it was done like this. So in our case, we designed something like this. So when you want to test your broker, you don't want to connect it to a real message queue because that takes a long time. You have some side effects if you have some messages in the broker before. You want to reroute your broker to use an in-memory broker, which is every time put up and tear down when you start up a test Kafka broker. So it takes your real FastStream broker, it patches its consumers and producers inside so they don't go to the real message queue, and does all the messaging in memory. It's faster, it's cleaner, you don't have any side effects. So to check if you're getting some messages from the prediction topic, we will, inside of our test, add one more subscriber so that we can listen to the predictions that our model is producing. And then we send some test data to a broker. After that, we can check if our broker has consumed those test messages. So we access the mock assert called once with, and our on input data, we can check that it was called with input data 0.2. And the last step is we can do the same for our subscriber. So we can assert that it was called with the prediction of score 1.2. So wrapping it all up, to serve your broker, you need to wrap it up into a FastStream object. This object takes care of all the lifespan hooks, serving, and also the documentation. And to serve this object, you just need to, in your CLI, you need to run FastStream run, pass in the module or directly the local file application, and the symbol of the app that has a type of FastStream that you want to run. It will parse your Python files and import the application and run it through Python. What's nice about this, you can always scale horizontally because we also have an option to define the number of workers you want to run. It will run your application side by side, sort of like having multiple containers for an application in different multiple processes. So if you want to make it faster and you have multiple CPUs, you can always make more use of them. So one of the things that we also needed to do is to find a way to integrate it with FastAPI, because we do have some REST API requests from our customers. They want to check the health check or access the documentation and things like that. So we implemented it to integrate the Fast Kafka or FastStream into a FastAPI application. We have a Kafka router. It's basically a wrapper around a Kafka broker, which is compatible with FastAPI. So then the FastAPI can dissect the router and generate the documentation for you. So first you create the broker that's compatible with FastAPI. Then you define your subscriber and publisher logic. So what's the type of incoming messages, or where do you read from, where do you write to? And after that, you just include it into FastAPI. So the first line takes care of starting and stopping the broker at the same time when FastAPI is getting started and stopped. And the second one is FastAPI has a way of defining parts of your application as routers in different files, and then you need to include it into the FastAPI application. And to run this, you run it as a normal FastAPI application, so UVcorn application up, and everything will start up. Now let's take a look at some implementation details about what we did inside of FastStream. The code will be a bit simplified, but I think you'll get the idea. So first is decorating the consumes and produces. This is like an example of a decorator for those who don't know. In this case, you just define your decorator function, define a wrapper function, and wrap your original function that you passed into a decorator function, and return the wrapped function. After that, okay, it's fine. So after that, to decorate it, you just replace your original function reference with the decorator function in which you pass the original function. The usual way, I believe, that people are used to is this. So this is a decorator syntax sugar. The past slide shows how it's done in Python under the hood. So to decorate this grid, you just do @decorator function. So how do we do it for our publishers in our FastStream? So in our class broker, we have a list of all publishers, and then we define our publisher decorator, which will take in the function that we want to connect to the publisher. And inside of the wrapper, we first call our original function to get the return value. And when we get the return value, we publish it to a message queue. And just to make everything tidy, we return it to the user. Yeah, so one neat thing about this is that inside of your decorators, you can also, if it's a decorator inside of a class, you can append it. So we register it to start up the publisher when we call async def start of our class broker. And that's how this broker.publisher works. So it will take your own input data, it will wrap it up inside of a wrap publisher, it will call it. When you call this function, it will call it then, get the prediction, a return value, and then publish it to whatever broker you're connected to. For the consumers, it's a bit simpler. So because we don't need to like record the return values and produce them to our brokers, so we also have a list of handlers. We used to call them consumers, but when we introduced Propan and when we introduced Nats and Redis, we saw that like more people are using handlers, and Kafka is like usually consumers and producers. And so you define your subscriber decorator, you link it to your handler, which will, when you get some messages into your queue, will call this function with those messages. And then you register it to be started up when you start up your broker. So yeah, when you call async dev start, it will go through all of the handlers and call start on them. The next thing is the way we reroute our traffic for testing, for testing in memory. We are using context managers. So this is a basic example of a context manager. You have an enter clause, you have an exit clause. When you use with context manager, first thing that happens is the enter clause gets executed. Then what's inside of the context, so this print inside gets executed, and when you're exiting the context manager, the exit clause will get executed. What's really important for us in this case, you can see that exit takes some parameters like exception type, exception value, and traceback. Basically, context managers guarantee to you that whatever happens inside of the context, so while we're printing this inside, if you get some exception, the context manager will always execute the exit clause. That's why it's a good practice to open your files with context managers, because if you do something wrong and you get an exception, the context manager will take care of closing that file for you. In our case, it's really important that we stop our broker so that we don't have some processes hanging after the tests, even if they fail. And as we are using the async library underneath FastStream, and also we need to wrap it inside of an async context manager, it's basically the same as a normal context manager, but you just append a in front of enter and exit, and you're done. And this will execute your async def main, and it will print entering inside and exiting. In our case, it looks quite something like this. So when you define your test broker class, you pass in the broker, and when you enter it as a context manager, it will patch up your broker to the consumers and producers will be in memory, not connect to the real broker. And when you're done with your tests and you're exiting the context manager, it will clear everything up and stop the broker for you. So now is probably my most favorite thing about this project, which was really interesting to me. So the documentation in FastStream looks like this. And you can see that we have a code block here. And what's really interesting in Git, so the documentation looks like this. So it's a markdown file which will be then processed by mkdocs to create what you've seen on the previous slide. But the code is not here hard-coded. It's been referenced from a file. And that file looks like this. So it's like a real Python file in our source code. And if we can reference this code inside of real Python files, we can also test it. So this really guarantees for us that when we write our documentation and we connect it to our code, it works. So if you come to our documentation and copy paste something, we are 99.9 certain that there won't be like any syntax errors. The like functionality we are like giving to you has been tested. So because when somebody like goes through a documentation, especially if their first time, they will start to like go through the demo and copy paste things from the demo. And if it doesn't work, like in the first 3 copy pastes, the people will just leave. So nobody will use it. And you won't know that your documentation is not working, especially like in the first parts of the documentation, because people usually have, they like report bugs at the moment they are invested into the library, and they're not invested in the first 30 seconds that like they're going to the basic demo. So it's really, really important that your documentation is tested. Yeah, and we have a bit more time to talk about the development environment. So what tools are we using inside of our development environment? So to deploy, to publish our application, our library to the PyPy, we are using Hatch. For executing our tests, we are using PyTest. It's like a really nice library. I think it's like more or less a standard. And to like parse our documentation from what you've seen like in the READMEs, not READMEs, but markdowns, so we are using MPK docs. It like takes all your markdowns and deploys a site for you with the documentation. And one of like cool things to use also is pre-commit. So if you put in your PyTest and your linting and your static analysis into pre-commit, it will not allow you to commit something that's like stupid or doesn't work because it will fail. So it happens before you commit anything to Git. For our static analysis, we are using SameGraph. So SameGraph and Bandit, we had some experience of accidentally pushing some secrets into Git at the start, but yeah, we've learned to like be a bit more careful. And it really increases the like trustability of your code. It will catch a lot of security issues for you. And also we are using MyPy, so you don't need to define types in Python, but it's really recommended because then MyPy will catch a lot of like stupid bugs for you, and you won't spend like a minute on like if you're sending a string and you're expecting a list and you're trying to iterate through it or some similar things like that, MyPy will warn you immediately. So no more wasting time or on like sending wrong types of objects. And also, yeah, for like improving the quality and readability of our code, we were previously using iSort and Black, but we are now using Rough. It like has plugins for iSort and Black. The iSort like just makes your imports readable and like in like a structured format, and Black takes care of formatting your code. So no lines will be too long, or like naming of the variables, it can also warn for that. So it just makes your code look professional, and it's no cost. So you just run Black and it will like clean up all your files for you. And the last thing that we learned, so we had a contributor like 2 months ago who committed code spell for us. So we had some typos in our documentation. And we didn't know that there was a like library that will go through your code, go through your markdowns, and like spell check it. To be honest, we also had one like trick. So people usually like to contribute to a project, but do it in like small stuff. So if somebody sees a typo on your project, on your documentation, they will like be really up for it to like make a merge commit to merge request to like fix your typo. So we did some like typos intentionally to lure people to start contributing, but after code spell, that's like not an issue anymore. And yeah, some tips and tricks that we've learned in the past year of developing this. So yeah, sharing is caring, and it's very beneficial for you. We initially developed it for our internal projects, but after like people started using it, they've requested new features, they requested bug fixes, and basically when you have something open source and you're also using it, you're using the people that are using your library as testers. I mean, it has to work initially, but they will fish out a lot of bugs for you that won't bite you back when you're starting on your project. And a lot of those features, we are now seeing that we really needed them in like 3 of our projects that we are like almost done, in almost ready to push into production. Next thing that was really interesting for me is you probably heard about test-driven development. I think the docs-driven development is also a term, but before we started like programming anything, we like to like first write the docs, then write the code in the tests that we'll reference in the docs. First make those tests like skip, and then write the functionality that will like make those tests work. It really helps you if you start with the docs. You don't need to like after you finish like programming something, you don't need to like start to recall what did you do and lose like a couple of hours on the documentation. And I hate to write it, and it helps you like better understand your API. So when you're writing documentation, you will much sooner see if something like makes sense in the sense of the API of your library than if you're like immediately digging out into the code. And when you're working on something open source, like set a deadline with something concrete. When you have like a customer, you always have deadlines, and he'll make sure that you like reach them. But when you're working on something open source, virtually nobody is forcing you to continue working on it. And one of the reasons we've managed to like publish Fast Kafka in like April last year, and also publish FastStream in like September last year, was because we had these talks. So we had some deadline at which we had to present something. So these talks are really beneficial for us also because they give us some like date on which we have to have something ready. And yeah, don't release on Monday. It was really interesting to us to notice that we tried to release, we wanted to get traction with this library, and we needed to have like user input. And we've noticed we've tried to release on each day in the week. And the Monday was like, in the matter of response of the people and new people coming was the worst. And then we took a look at like our development and how we do business in our company. We've noticed that on Monday, we usually like clean our emails, do our like weeklies, plan our tasks, start working on them. You don't really have much time to like experiment with new libraries. So usually when we released on Monday, we concluded that people are like busy with their own work and they don't have time to like experiment with something new. So if you want to get traction, I would recommend any other day, but Friday, because you would ruin your weekend. If you break something in your library, like people will test it over the weekend because they have the most time then, and like you want to rest. And yeah, that's it. So here is the link. You can go on our GitHub. You can open a bug, open some pull request, comment, request, and like a feature. Just try it out. Maybe you'll like it. We're also available on Discord, so you can contact me or contact anybody from our team. We will try to answer you promptly. And yeah, special thanks to Nikita, Davor, Heidi, Harish, Kumaran, and Robbie. That is like the team that was working on this, and like I would really like to especially thank Nikita, because in the past 3 months we were working on our internal projects, and he was like the driving force of solving the bugs and talking with people. Hopefully, like in the next couple of weeks, we'll also start to communicate more with our users. And that's it.
Great, thank you so much, Tvrtko. All right, we have a couple questions for you. So how about using FastStream with non-async frameworks?
Yeah, so we decided to use async because the libraries underneath are really async in nature. And if you have our endpoints to use them as something sync, it really doubles the logic of your application. So people will try to use it interchangeably. People who don't know how to use async will try to use it as sync. And we've noticed, I think, also in FastAPI, there were a lot of comments of their applications being really slow because of the junior developers in their company that work on the code were interchanging the sync and async endpoints, which doesn't mix. And yeah, basically we want to force good practices of using async code with messages, because message queues by themselves are async in nature, so it makes sense to keep this as it is.
Great, thank you. All right, so how is Fast Kafka faster than Kafka? Does it still run in JVM?
So yeah, Fast Kafka, we've done some benchmarking tests on the existing libraries that are in Python for connecting to Kafka, and well, as you would guess, we with our decorators and handling our functions, we do put a little bit of overhead. So we're 1 to 2, I don't know, % slower than if you would use the bare bones engines that we are building on top of. It's mostly the quickness that we are counting on is your development experience and the testing experience. So you will save a lot of time on the development and testing. In the production, if you really need that 1%, I mean, you can opt out for using the underneathing libraries, but then we're using Python. You can always write something in C. So yeah, we're a bit slower, but in your experience as a developer, we're much faster.
All right, so let's see. Are subscribers limited types? For example, can I consume on a Django app?
Yeah, I mean, in our documentation, I've taken FastAPI as an example, but integrating with a Django app, it's completely possible. And in our documentation, we have I think Django is also included. You have code that you can copy paste, similar to the one that I've shown in the presentation for FastAPI, and you'll be integrated with Django.
Great. All right. And have you considered renaming the project to Butane? What a power couple would that be?
Yeah. To be honest, I never asked Nikita, but I don't know why he called his project Propan. It's Russians and gas, but. We in the end, our fascination with FastAPI and the way it's really nicely constructed overloaded his decision of calling it propane. So in the end, we decided for FastStream. That's why we called it Fast Kafka in the first place. So we took a lot of inspiration with the decorators and everything, and also I think the testable documentation. The scripts to inject your code into the documentation is taken from FastAPI.
Awesome. Thank you so much, Tvrtko. Round of applause.